Alrighty, in 8.2, we're going to be graphing quadratic functions from vertex form. So we're going to talk a little bit about some different features of these quadratics that we learned to graph in the last section. So the first quadratic we're going to graph is y equals x squared minus 4. So let's go to our calculators and go to the y equals, and we're going to type in x squared minus, make sure you use a minus, 4. Once you have that typed in, we're going to go to the graph just to see what it kind of looks like. It looks like we moved our graph down a little bit, but I really want to see what those points are. So we're going to hit the second graph so we can see the table and what points I need to plot. So I'm going to plot all of the points that I possibly can on my graph. It looks like the first one I can plot is -3, +5. And then I can graph -2, 0, -1, -3, 0, -4, 1, -3, +2, 0, and +3, +5. So once you got all of those plotted, connect your dots. And first off, I can tell that my graph is opening up. And then we need to identify the vertex. So that vertex, remember, is either our highest or our lowest point of our graph. So it looks like that's this point right here, which was the point 0, -4. I can see on my table in my calculator just to double check that that was the point that I had. Okay, then I want to see what is my y-intercept. Where am I crossing that y-axis? And it happens to be the same as our vertex. So we are crossing that y-axis right here at that same point 0, -4. Okay, then we need to figure out where we're crossing the x-axis, or x-intercepts. So we're crossing twice. So that's this point right here, which is, if you look at our table, -2, 0. And we're crossing another spot right here at, if you look at our table, +2, 0. Give myself some space here. Okay, then we need to identify our axis of symmetry. Remember, that was our line that cut straight through our vertex vertically. So our line that cuts straight through is going to be right here in the center of our graph. And that's if we folded our graph perfectly over that line, it would be perfectly symmetrical. So whenever we write our axis of symmetry, we're going to say x equals, because we have a vertical line, and we crossed through, x equals 0. Okay, then we're going to say our domain and range. This is something we haven't talked about in a couple chapters, but it's never really going away. So let me remind you how to find your domain and range. Let me use a lovely lightsaber as my vertical line. So remember, you take a vertical line across your graph, and wherever you start to touch, that starts your domain. So if I drag my vertical line across my graph, I start to touch on an arrow. So that means I'm starting at -infinity. And whenever you have an infinity, you have to use an parentheses. Okay, then the last time I touch my graph is at another arrow, so it's going on and on forever towards +infinity. So I'm going from -infinity to +infinity. Okay, then you need to drag a horizontal line across your graph. So if I were to drag a horizontal line across my graph, the first time I start to touch is down here at -4. And I am at a point on -4, so I'm going to use a bracket. Okay, then when I keep going, I finish at the top touching 2 arrows, which mean I'm going to positive infinity forever and ever, and I have to use a parentheses. Okay, let's try another one. Now we want to graph y equals x minus 3 squared. So let's go back to our y equals, and let's type it exactly how it looks. We got to use those parentheses as well. So parentheses x minus 3, close that parentheses, and then squared. Make sure it's typed exactly how it looks in your notes. Okay, now that we have that, we're going to look at kind of what our graph should look like. And it looks like it shifted to the right this time. So we need to go to our table and find, so hit second graph and hit as many points as we possibly can. So it looks like 0, 9 is the first one we can graph. 1, 4 is the next one we can graph. 2, 1. 3, 0. 4, 1. 5, 4. And 6, 9. So once you have all those plotted, connect your dots. And we can see that it still opens upwards. And our vertex is down here at the lowest point of our graph, which was the point 3, 0. So our vertex is a minimum at 3, 0. Okay, then I need to identify where we're crossing the y-axis. So we're crossing the y-axis up here at that first point we plotted, which if we check on our table was the point 0, 9. Then we need to see where we're crossing the x-axis. So we're crossing the x-axis actually on our vertex as well, which is the point 3, 0. And it's only 1 point, which is okay. Okay, then we need to identify our axis of symmetry. So let's make that line straight through our vertex vertically, which was, first we have to write x equals, and it was cutting through x equals positive 3. Okay. So now we need to do our domain and range. So I'm going to vertically go up and down until I start touching my graph, which, I happen to start touching at 0, but I'm touching an arrow. So I'm going to negative infinity. And then I continue to go, and the last time I touch my graph is at an arrow again, which means I'm going to positive infinity. Okay, then for range, I'm going to horizontally go across my graph until I start touching, and I start touching right here at 0. So I was touching at 0, and I was equal to, so I'm going to use a bracket. And then the very last time I touch my graph is up here on 2 arrows, so I'm going to positive infinity. Okay, let's look at another example. Now we want to add to that last one that we did on our y equals. So we have x minus 3 squared in our calculator already. Now we want to add on minus 4 onto the end. So let's use that in our calculator. And we want to hit graph first. So it's still shifted to the right, but now it looks like it's shifted down as well. So we're going to go to our table to get some of those points, second graph, and we're going to plot all of the points that we possibly can. So 0, 5, 1, 0, 2, -3, 3, -4, 4, -3, 5, 0, and 6, 5. Okay, once you get that graphed, let's identify some of the parts of our graph. So I can see it still opens up. And then let's find where that vertex was. It still looks like it's the lowest point of our graph, a minimum. And it's down there at the point 3, -4. Okay, let's find our intercept. So our y-intercept, where we're crossing that y-axis, was at 0, 5. Okay, then we need to find where we're crossing that x-axis, which this time we're crossing 2 times, so we're going to have 2 different points. So we have the point 1, 0, and the point we're crossing at 5, 0. Okay, now we need to find our axis of symmetry. So let's make that vertical line straight through our vertex. And whenever we write an axis of symmetry, we have to say x equals, and it cut through x equals +3 again. Okay. Now that we've done that, let's do our domain and range. So I'm going to go horizontally up and down until I start touching my graph, which I happen to start touching at an arrow, which means I'm going from -infinity. And then if I keep going vertically, the last time I touch is +infinity because I'm touching an arrow. Okay, then for range, I got to use a horizontal line back and forth. And the first time I start touching is at the point where I'm hitting at -4. So since I touched a point, it's going to be a bracket. And then the last time I touch my graph is at 2 arrows. So that's going to be headed towards +infinity. Okay, let's do another example. So now it looks like we're changing our negatives to positives. So let's type in x + 3 squared + 4. And we're going to go to our graph and see what it looks like. So now it looks like we're moving to the left and up this time. So notice kind of what's happening with these movements in our graph and what our equation is looking like. We're going to talk about it at the end. So when I have this, I'm going to go to my table because that's really where I want to get those points from. And I want to find as many as I possibly can. It looks like it's going to start at -5, +8. And then we could go to -4, +5, -3, +4, -2, 5, 1, 8. Okay, so we connect those dots, and we're still opening up. And now our vertex is right here. We're still a minimum because we're still the lowest point of our graph. But our vertex was -3, +4. Okay. Now we need to find our intercepts. So our y-intercept, it doesn't appear to be touching our graph. But I know that if I were to continue to graph on a larger graph, my line would continue to go and it would eventually hit that y-axis. So let's look at my table and see if I were to continue graphing my next point. So I graphed that 1 or -1, +8, but then if I were to graph 0, I would be up here at 13. So 0, 13 is my y-intercept. So remember, whenever you have an intercept, if you have a y-intercept, your x is going to be 0. If you have an x-intercept, your y is 0. So if you want to write yourself a note, it's always the opposite is 0. Okay, so we want to find our x-intercept. So we want to look at our x-axis, and it doesn't look like we're actually touching the x-axis. So we're going to say we have none because we're not touching that x-axis. Okay, now we need to graph our axis of symmetry. So let's make that vertical line straight through our vertex. And whenever we write an axis of symmetry, we're going to say x equals, and it looks like we cut through -3 on the x-axis. Now I need to do my domain. So I'm going to go up and down until I start touching. And the first time I touch up and down is on an arrow. So I'm going from -infinity. And I continue to go up and down. And the last thing I touch is another arrow. So I'm going to +infinity. Okay. Now if I go up, back and forth, the first time I touch is right here at +4. And I was touching on a point, so it's going to be a bracket. And the last time I touch is all the way up here, but I'm touching 2 arrows, so that means I'm going forever to the positives, +infinity. Okay, so we got one more example. Let's look at it. We're going to graph 2x + 1 squared -5. So let's type that in. 2 parentheses x + 1 squared -5. Make sure you type that in your calculator correctly. Okay, so we're going to hit graph just to see what it looks like. Okay, and then we want to go to our table's second graph to get all those points we can possibly graph. So it doesn't look like we have too many. The first one being -3, +3. Then we got -2, -3. -1, -5. 0, -3. And 1, 3. So let's connect those dots. And it looks like we're still opening up. And our vertex is all the way down here. It's our lowest point of our graph, so a minimum. And that point was -1, -5. And now we need to find our y-intercept. So that's where we're crossing that y-axis, which was at the point 0, -3. Okay, now we need to find our x-intercepts. So our x-intercepts are right here and right here, but they're not at exact points. So since they're not at exact points, we're going to have to find them on our calculator. So we're going to go back to our graph, and we want to find exactly where that's crossing. Okay, so we're going to talk about this in class together. So leave that one for us to talk about in class. Okay, let's find our axis of symmetry. So that's that vertical line straight through your vertex. Okay. And that's at x equals, and we cut through -1. Okay. Our domain, we're going to start off by going up and down, and it looks like the first thing we hit is an arrow, so we're going from negative and infinity. And the last thing we touch is up here at an arrow again, so we're going to positive infinity. Okay, for range, we're going to go back and forth until we touch something. Oh, and it looks like we touched down here at -5 on a point, so we're going to use a bracket. And the last time we touch is all the way at the top at arrows, so we're going to positive infinity. Okay, so we talked about kind of how our graph was shifting, but we didn't talk about why. So we're going to talk about what those different things did, what this A did, what this H did, and what this K does. So we talked about in the first unit when we had a 2 in front, it made it skinnier. When we had a 1/2 in front, it made it wider. When we had a negative, it flipped it upside down. So our A can do a couple things. It can make it skinnier. It can make it wider. Or it can flip upside down. So lots of things it can do. Now that H, that was in this section. If we look back, so our original graphs were always in the 0, 0 area. All our axis of symmetries were at 0, 0, straight in the middle, straight in the middle. But now when we had something with that number in the parentheses, it shifted our graph to the right each time. If we had something with a plus, it made it go to the left. So it looks like that H can make our graph go right or left. If we had something on the end, like we had this one, we moved down. This one, we moved down as well. This one, our graph moved up. Oops. And this one, our graph moved down. So it looks like our graph can go up or down whenever there's a number added or subtracted on the end.